Okay, this is Lewis Katz, and this is hopefully the only second cut of my first Jing glaze calculation cast. We are going to be working today with this recipe, alkaline glaze. You notice it's backwards here. I'm not going to bother turning it around here. I'll turn it around in the glaze calculator so you can see it. This is from an old book I bought at Half Price Books, Ceramic Processes by Mary Chase Stratton. She ran the Poabic Pottery in Detroit for a long time. The book is, well, it's signed by someone in 1941, and it's dated 1941. I believe it was written in 1938, but I could be wrong. There's also a date in there in 1940. Anyways, I'll get the photo booth out of here, and we're going to go into the glaze calculator. This is Hyperglaze, Richard Burkett's glaze calculator, and I'm going to go down into the glaze index. There's the glazes. The glaze index is over here. Everything's pretty small here because I don't want to capture a big window because it'll just get shrinky-dinked when we go over. Let's see, what is this thing called? I actually don't know. Maybe alkaline base. If we don't find it soon, we're going to have to take 3, aren't we? Looks like take 3. But I'm remembering an M, so let's just see what happens here. MC Stratton is what it should be called. It's in mid-range, maybe. I really think it's a cone 10 glaze. Here we go. MC Stratton, alkaline, D1. This is the original glaze recipe. If you notice, it says sodium silicate here, kind of an odd ingredient for a glaze recipe. She probably means a dry powder. We're used to seeing it dissolved in water. It's soluble in water. It's bound to create all kinds of problems, soak into your clay, come out in little crystals, who knows what else. But if you look at the molecular formula here, if you're used to looking at the molecular formula, you can notice that the potassium and soda here are about just under 0.6 moles, and the calcia is just over 0.4. It's kind of high in soda and potassia, and that makes it a difficult glaze to calculate. The aluminum and the silica are within sort of normal range for a stoneware glaze, so we're going to take a look at it and see if we can't make it with some slightly better, easier ingredients if we just alter the glaze a little bit. So I'm going to go over to the glaze calculator, and you can see I've been playing with it over here. Here it is with cryolite, but that's not what I want to do. I want to get the current glaze. Here's the current glaze, and I want to get rid of all these ingredients. And the first thing I'm going to do is I'm going to move some of this over to here. This says 0.449, and I am going to lower that to 0.35 and go down here, and that leaves 0.1 for magnesia, and that'll add us up to 10. Great, and that'll take care of that. We're going to change this to container glass, because it's a place where we can go and get a lot of potassia and take care of some things. And we'll see what happens when we calculate here with container glass. We've taken care of most of the potassia. We still need some more magnesia because the average container glass has some magnesia. Let's go and just see what it says over here in Materials Index. I've got container glass. That'll bring this up here. And so it's got equal parts of potassium and soda and calcium and magnesia. So that's pretty much what we're going to need for that recipe. So we're going to go back to the glaze calculator and clear the amounts. And we're going to increase the amount of magnesia yet again. We'll call it 2 here. And that means we have to decrease